Alright, so what we'll be looking at now is so we're still on matrix. So what we're going to be looking at is next thing in the syllabus is addition and subtraction of matrix of the same order. Alright, so we're going to look at addition and subtraction of matrices. So addition and subtraction of matrix. That's what we're looking at now. So remember, when we're adding or subtracting matrix, they should be of the same order. So so this is matrix A. Let's say matrix A is a 2 by 2 matrix. So it has 2 rows, 2 columns. So 2, 3, 1, 4. So this is a 2 by 2 matrix. So remember, they should be of the same order. Sorry. So matrix B is, let's say, 7, 4, 2, and let's say 5. So we're going to find first one A plus B. Now A plus B is matrix A. So remember, this is a 2 by 2 matrix also. Matrix A, which is 2, 3, 1, 4, plus matrix B, which is 7, 4, 2, 5. Now remember, when you're adding or subtracting matrix, they have to be of the same order. This is a 2 by 2 matrix. This is also a 2 by 2 matrix. The result should be the order of the original matrix, which is 2 by 2. So when adding matrix, we add the corresponding values. So this is A, this is B, this is C, this is D. This is A, this is B, this is C, this is D. So we're going to add A with A, B with B, C with C, D with D. So we're going to have 2 plus 7, that's 9. 3 plus 4, that's 7. 1 plus 2, that's 3. 4 plus 5, that's 9. And if you realize, we put them back in the same position that we took them from. So that would be the result for A plus B. Let's try another one. I'm going to use subtraction now. So let's say we're going to find B minus A. So B minus A, matrix B, is 7, 4, 2, 5. Subtract matrix A, which is 2, 3, 1, 4. So remember, when you're subtracting matrix, they have to be in the same the same order. So I remember we're subtracting whether we're subtracting or adding, we add or subtract the corresponding values. So let me use this. So probably on a block. So it's 7 minus 2. We know that 7 minus 2 is 5. 4 minus 3, that is 1. 2 minus 1, that is 1. And 5 minus 4, that is also 1. So this would be our result for B minus A. Adding or subtracting matrices it's very simple. So as I said, whenever you're adding or subtracting them, you add and subtract the corresponding values. So let me do one more example before move on to something else. So let's say we had another matrix C. So I'm going to introduce C. Let's say C is 3, 4, minus 1, and 0. So what we're going to find A plus B minus C. So that's what we're going to solve for. So matrix A is 2, 3, 1, 4, plus matrix B is 7, 4, 2, 5. Matrix C is 3, 4, minus 1, and 0. Now, what you could do is just add the corresponding values. So it's 2 plus 7 minus 3. So we could do it like that, or you could do a plus b first, then afterwards you subtract c. So remember that we had already solved for a plus b. So a plus b, so anywhere I say a plus b, all of this is equivalent to this. So a plus b is 9, 7, 3, and 9. This is the result for a plus b. Now minus c. Remember, this is matrix C, so I'm going to have 3, 4, minus 1, and 0. So I'm going to have 9 minus 3. That is going to be 6. 7 minus 4. That is 3. 3 minus 1. Remember, negative times negative is positive. So this is actually 3 plus 1. That is going to be 4. And 9 minus 0. That is 9. So this would be the result for a plus b minus c. All right, so what the next thing in the syllabus? The next thing is where is that? Order, same order. Scalar multiples. So let's switch this to another sheet. So scalar multiple. Now let's say we had a matrix A. Matrix A is, let's say 1, 2, 3, 4. This is matrix A. And we want to find like 2A, for example. Now this 2, we consider it as the scalar multiple. The 2 is a scalar multiple. So we're multiplying a 2 by 2 matrix by 2. So 2A, 2 times A is actually 2 times what A represents. A represents the matrix 1, 2, 3, 4. So I'm going to multiply each term in the bracket by the scalar multiple, which is 2. So what I'm going to have for the result, I'm going to have 2 times 1, which is 2, 2 times 2, which is 4, 2 times 3, which is 6, and 2 times 4, 8. So that would be the answer. So let's load another one. Let's say we're going to find half A. So half A would be equal to half of what A represents. 1, 2, 3, 4. So half of 1 is a half. Half of 2 is 1. Half of 3 is 1.5. And half of 4 is 2. So this would be the result for half A. Now hopefully students understand that. So let's reverse a question. Let's say that they said that we introduce another matrix. Let's say we introduce another matrix B. And B is 1, 0, 0, 1. So if your memory serves you, you would remember that this is the identity matrix. So let's say we're going to find 2A minus 3B. So this was question 1, question 2, question 3. 2A minus 3B, that's what we're solving for. So for 2A, we already solved for 2A already, but I'm going to redo it. So we have 2 times what A represents, which is 1, 2, 3, 4, minus 3B. So we have 3 times B. B is 1, 0, 0, 1. So what we're going to do, multiply each term in this by 2. So we have 2, 2 ones 2, 2 twos 4, 2 threes 6, and 2 fours 8. Minus 3 times 1 is 3. 3 times 0 is 0. 3 times 0 is 0. 3 times 1, 3. So we're going to subtract corresponding values. So it's 2 minus 3. That's going to give us minus 1. 4 minus 0 is 4. 6 minus 0 is 6. And 8 minus 3, that's 5. So that is the that would be the result for doing scalar multiples. So remember, the 2 would be a scalar multiple, and right here the 3 would be a scalar multiple. So that's it for this one. I think I might join all the videos together to make just one video on matrix, then do another one with some past paper questions. All right, so in the next video, or the next section of the video, we'll be looking at multiplication of matrices.